The views expressed on Science for the People are not necessarily the views of this station, its affiliates, sponsors, or advertisers.
This week on Science for the People, we're talking about geology. But not the geology here on Earth. That's been done. No, we're talking about the geology of salt planets, desert planets, and all the other worlds we find in science fiction. Hi everyone, Bethany here. What you're about to hear is a panel I moderated on September 3rd, 2018, at the Dragon Con Science Track in Atlanta, Georgia. We got a panel of experts to talk about how physics, plate tectonics, and even the weather might work on the fictional planets we love, from fantastical worlds like Star Wars to more realistic ones, like The Martian. Check it out. Here we go. Welcome to Science for the People. I'm Bethany Brookshire, a writer at Science News and Society for Science and the Public. And we are here at Dragon Con today because we love sci-fi, the future, worlds that our authors build. And a lot of that world building is a bit surface level, as it were. You get magic systems, you get the Force, you get, various high-tech battles play out. Humans and non-humans crawl around on these planets. But often the planets themselves end up rather ignored. They're just a surface on which our humans or non-humans are blasting lasers at each other. And today we're going to talk about what lies beneath our own planet and the planets to which we boldly go. And I have a degree in pharmacology. I know nothing about this topic. I can look at a rock and say, that is a rock. That also is another rock. And so luckily, we have an all-star panel to help us out. I am grateful to turn it over to our talented panelists. So if we could go down the line and briefly introduce yourselves.
All right. Good morning. I'm Scott Harris. I am a planetary geologist and staff scientist with Fernbank Science Center, about 3.5 miles down Ponce over here. And while I have a very diverse background in geology, for the last 20 years, I've specialized in asteroids hitting things.
You and me both.
I'm Trevor Valle. I'm the former lab supervisor of the Liberated Tar Pits, National Geographic's Ice Age paleontologist guy. And I also, being out in the field a lot, know a lot about geology. And you totally taught me on the asteroid impacts, and that's rad.
All right. My name is Mika McKinnon. I am a geophysicist and disaster researcher. And I'm a Canadian geophysicist, which means I actually went through a wedding ceremony with my work, and I wear a little silver ring with rock hammers and seismic seismic signals to confirm that I will be in a giant marriage with all planets and all other Canadian geoscientists. Geophysics is like a mix of James Bond villain and MacGyver. We try and figure things out without actually touching them, usually by blowing them up and having it not work. And then in terms of an extra bonus bit of context, I also work in the entertainment industry as a science fiction scientist. So I help writers come up with more plausible plots, or I'm the stunt handwriting for the actors, and I try and find ways to get more science into the stories we're all enjoying.
Thank you. I actually just think it's so romantic to be in like a marriage with your scientific field. And I'm going to propose to pharmacology immediately after this panel, if you would like to live stream it.
My name is David Moscato. My master's is in paleontology. I'm currently an educator, among other things, at, I should put my hat on, the Gray Fossil Site, Natural History Museum in East Tennessee. I also host the Common Descent podcast, which is a podcast about paleontology and Earth history and such. And being a paleontologist, for me, means that most of what I know about geology I learned on my way to learning about biology. I have to go through the rocks to get to the stuff that I want.
So let's start talking about some rocks. We're actually going to start planetary level, because when people start thinking about sci-fi planets, I think the first thing that leaps to mind... the first thing that leaps to my mind is Tatooine, followed by Jakku, followed by the planet in Dune, which name I cannot remember at this time. Thank you, Caracas. And other desert planets. And so I was wondering, Scott, could you talk about real-world desert planets and what they are like?
Well, I would imagine that desert planets are the rule, because most of the planets that are out there are in star systems that are a little bit more complicated than our one star system, and a little bit more like the system at Tatooine, where you're likely to wake up to multiple blazing suns or never actually go to sleep to any sunset at all.
It's like Dragon Con.
Yeah, but even brighter. And as hot as Atlanta is, probably even hotter. Although sometimes maybe not. But the thing about Tatooine and the other ones you mentioned is there's something else there that may not be on all of those desert worlds, and that's sand. Bare rock, just baked in the heat of those suns, is probably the rule. But in order to have that sand, you've got to break that rock down into sand, and that would imply that a little bit more complex evolution of those bodies where some water is probably involved.
So in order to get sand, you have to have had water in the past?
To get that rock broken down, those sand-sized particles, it's definitely going to help. Now, I said I do impacts, so impacts can break things up too, but to get pretty nice, what you call sand, out there, there's a good chance that there has been some water there, and that probably gives you an indication that the climate has changed over time on those worlds.
I'm going to jump in with a little bit of jargon here. So in geology, sand is a technical term. So you can tell the difference. We classify grains of things by how small they are, and how small they are actually impacts the texture. So the easiest way to tell the difference between sand and silt, sand and mud, is you chew it, and if it's gritty, it's sand, and if it's not gritty, it's mud. If you're not fond of eating rocks, which, is a little bit tragic, but, if you are not fond of eating rocks, you can also put it in your hand, spit in your hand, because you're going to get saliva in this no matter what, start rubbing it around, and if it falls in those tiny little wrinkles in your hand, it's silt. If it doesn't, it's sand. You will now notice both paleontologists have pulled out little wallet cards that include size scales for different types of sediment, along with little measurement scales so they can take photos of things and have an object for scale. I don't have one. I'm a geophysicist, so I bring a small plush moose with me instead. Or for the really small stuff, I bring a loonie, the Canadian money currency that we swear is real.
I just, as a former pharmacologist, I shudder internally every time you guys talk about licking your study subjects. Don't do that.
We're gonna come back to licking things.
I hope
mud pies, like little kids eating mud pies. They were doing science.
Oh, yeah, no, we're going to be discussing a hero of geology a little bit later.
So, while I have your attention, Mika, we talked a little bit about desert planets and sand, but there's the opposite end of the spectrum because there are water worlds. So I was wondering if you could talk about water worlds and what makes them happen.
Yeah, so my favorite one in science fiction is very selfishly selected. It's in Stargate Atlantis, the Lantia planet in the Pegasus galaxy. And it's my favorite of a world which is entirely water, in which our heroes are living in a little force field protected shell, because I worked on the show. So I have a bias here, and I admit that. In real life, places where we find water worlds happen to have a layer of ice on top of them right now. And that would be places like Jupiter's moon Europa. Or more surprisingly and startlingly, and when these results were being results, I was live blogging them for a news site, and I literally hit the point where I just pounded on my keyboard in what is even happening? And I had to take a few minutes to regroup. Is that when the New Horizons probe went past Pluto, it found evidence of such geologically young terrain, things that were younger than the Rocky Mountains, that they must have had subsurface oceans in this cold, remote, distant part of the solar system with nothing big nearby to give it a gravitational massage and keep it warm. So it must have had that ocean created by an impact between it and its moon or something, and then held onto it for billions of years, which is so unbelievably cool. And if we're seeing that in our own boring little solar system where we have quite honestly a kind of pitiful collection of variety of planets.
Hey!
It is! We've got dwarf planets, terrestrial planets, gas giants, ice giants, and that's it! We got really nothing else in terms of worlds.
Mika, careful. I'm sitting next to the planetary geologist.
Yeah,
Don't
I
make
know.
him angry.
He likes to beat them up. Like, he likes to impact other things. I think we're on team, let's beat up the planets.
Sounds good to me.
Yeah, see, I get this.
We're on
Disaster people are teamed up.
We're on beat up the planets because we get to study everything that dies on them.
Right, that's what I was going to say. If we didn't kill them, you wouldn't have anything to study.
Exactly.
So here we go. We think the first theme of the panel is going to be let's murder the planet. It's more fun that way. But so water worlds and other places, what makes it really interesting when you have a surface ocean, so you don't have that layer of ice, is when you start thinking about the waves. So waves are the size they are because of wind blowing across the surface. And the longer that wind can blow, so uninterrupted fetch, the larger your waves can get. That's why Hawaii has such gorgeously huge waves. Or why some of the biggest rogue waves on the planet are off west coast of British Columbia, the south chunk of, or the southwest tip of Africa, and around the Antarctic. It's because you've got these areas of uninterrupted fetch where the wind can just blow and blow and blow and blow. And actually that strip around Antarctica is the closest that we can see here on Earth of what it would look like to have just ocean everywhere, where everything is being dictated by tides, by wind, and by, like, saline density and temperature. What you'd expect is enormous waves, unbelievable storms, and all sorts of really cool feedback loops.
So I would just like to talk for a moment about the phrase uninterrupted fetch, which is, in my opinion, what happens when fetch happens. That's a Mean Girls reference. I'm a little obsessed. And I love the concept of uninterrupted fetch. But like I wanted to ask about...
Every dog wants uninterrupted fetch, right? Like, let's play fetch, and then I'm not giving it back.
So I wanted to ask a little question about water worlds, because, of course, when we talk about water worlds in sci-fi, they almost always have islands of some kind. But you're talking about freaking massive waves. Do those islands have a future or a present?
Yeah. Alright, so you can get them. And you can get them by having, you're not going to have the same sort of plate tectonics you have here on Earth with, like, continents bouncing around as the cork and then all the oceans kind of subducting under them eventually and, like, pulling apart, building new continents, all of that. We're not going to get those continents bouncing on top because we don't have any continents. But you can get land in other ways, like Hawaii, which is, you can think of it as being the geologic equivalent of sticking a candle underneath the plate, and that hot spot produces enough melt that you start generating volcanoes. What's going to be cool about this is that we know what shape the islands have to have. Because it's going to be all oceanic plate, we know it's going to be low in silica. Silica is a mineral that's pretty much like, you can think of it as being like glass. And what it does is it traps gas. So if you have a lot of silica, it traps the gas, you get big explosive eruptions and pointy-shaped volcanoes, stratovolcanoes, so things like Mount St. Helens, Pinatubo, Krakatoa, all of that. If you have low silica content, like the oceanic plates, then the gas can ooze out, and you get gentle eruptions, effusive eruptions, and big dome-shaped volcanoes like we see in Hawaii. So, all of these ocean worlds, sure, they can have island chains, and it'll be a lot like Hawaii, where it, like, slowly builds up over time, and sometimes the island actually manages to, like, breach the surface and grow out, and other times the wave action erodes it away, and we'll end up with, like, beautiful sand dunes under the water. We'll have, like, a desert covered in ocean. It's not an oxymoron at all. It's all geomorphology. We expect the same landforms. It's just, air is a fluid. It just happens to be less dense than water is. It's true.
So while you brought up the subject of plate tectonics, I actually wanted to kind of pull in Trevor here to give us a primer on plate tectonics, because I admit I learned it once in middle school, and then I didn't.
Plate tectonics, the best way I've ever described it to a large group of people is that, because it's hard to envision huge, gigantic plates of Earth rubbing against each other and floating on effectively the surface of the Earth and crustal plates and all that. But take, those saltines you get with crackers, or those saltine crackers you get with soup, pardon me. Don't ever take them out of the packet. Just kind of crack it in a few places and then start rubbing them together. That's the lithos. That is the surface of the planet. Underneath all the water, underneath all the buildings and all that. It is literally huge earthen structures, these continental plates rubbing against each other. Earthquakes are when those slip or thrust or underthrust or move. Being from Los Angeles, earthquake capital of the United States, woohoo.
And Oklahoma's trying.
Hey, that's different.
Oklahoma has goals.
So, a very easy thing to think what plate tectonics is literally this gigantic puzzle floating on top of a magma ball. That's a real, very blasé way to put it. But plate tectonics is what also forms mountains. And all that, like the Himalayas, the Rockies, all that. It's literally plates going and undercutting one and shoving up the other. It's like mountain building is really cool. I heard the chuckle.
Scott has a comment.
We spend a lot of time in science education and geology trying to dispel something you just alluded to.
Which one?
The magma thing over the magma.
Yeah.
And the truth is weirder. I mean, if you don't know, what he's talking about there, you get this notion of them floating up on something, and that thing they're floating on is rock. It's not liquid, and you try to get anybody, even us, to completely comprehend, because we absolutely don't. The notion of rock moving through rock, that's what happens. These lithospheric plates sink, but they're sinking through hard rock and harder rock because the pressure increases as you go deeper. One little trick, if you ever want to kind of see this in action, is take some silly putty and get two different colors. Get one piece really hot and the other part go put in the freezer. Put them together, one on top of the other, or either way. Doesn't really matter, cold, hot, flip them around and watch what happens. Mm-hmm. And then the only difference between that and what we deal with is time, and lots of time.
Whole lot of time.
So what's fun about this is he corrected it's not a liquid, but it is a fluid. Which I also said air is a fluid. It turns out a lot of things in the universe are fluid. If you want to say everything tastes like dinosaurs, you can also say everything is a fluid, like even crowd behavior is a fluid, and it gets better. Because in all of our textbooks in school, we show this layer of the Earth as red. Because, it's warm. It's green.
Yeah.
It's actually green. It's like a mix between olive and pistachio green. For bonus fun, the sun is also green, so everything tastes like dinosaur, is a fluid, and is green. And that's your first order approximation of reality.
I'm so awakened right now. Okay, we talked a little bit about plate tectonics, and the plate tectonics we're talking about dealing with here are rocks specifically. But we've talked about desert, and we've talked about water worlds, and now I want to talk about what happens if your plate tectonics are made of salt. Trevor.
Oh, Crate.
Crate.
Last Jedi, Crate.
I love Star Wars.
It's like, how many here have seen The Last Jedi? I'm assuming practically everybody. Okay, cool. By the way, the aforementioned hero of geology in Star Wars is that one Resistance fighter. They're setting up. The First Order is coming after them. They're, looking at all of these guerrilla walkers and Kylo Ren's weird little hovering thing. And what does he do?
Liz, I have done that so many times. I can't help it.
How much have we tasted?
Oh, God.
Igneous petrologists recognize it on site. We don't have to taste it.
Oh, you're right.
I can't help it. I was in the Utah salt flats, and I was extremophile hunting. I knew perfectly well I was in the salt flats of Utah. You see it, as you're flying in, you land, you drive through it, you walk around, you're like, this is clearly salt. Scoop, lick.
Yeah.
Yeah, we're scared of biology.
It's instantaneous.
Scared of biology.
They're cute.
We really dig that guy. Most geologists really dig that guy. Because he's just like, salt. And the guy next to him looks at him like, the hell are you doing?
I'm teaching two different university intro geology classes, at different universities on Monday. And in both those classes over the course of the term, I will make all of my students lick halite samples.
Absolutely. And
they never want to do it.
No, they never do.
They're so resistant to that.
They think we're trolling them.
Oh, no. We troll them when we're like, here, lick this coprolite.
That would be fossilized dinosaurs.
So let's talk about salt planet plate tectonics, please.
Yes. So salt planet plate tectonics. So when I was doing research for this part of the panel, I assumed incorrectly that Crate was basically a huge salt ball. But it's not. They filmed that sequence in a area of Bolivia, which was a tectonically basin-formed salt flat because of the tectonics of the area isolated the saltwater basin. Then it faced rapid evaporation and literally created a salt flat, just like Utah, just like outside of Vegas, everyone else that's currently at Burning Man, different things like that. But what's amazing is that when the skimmers go by, they're knocking up that all that red. Some people hypothesize that it was some sort of like fossil bacterial mat or anything. Turns out
that was me, actually.
That was you. There were a couple papers that also talked about that. Turns out that is both red amorite crystal and rhodochrosite. Rhodochrosite, very, very large, stable crystalline mineral. I'm just trying to figure out if there were tectonics, and there had to have been in order to create that basin. Crystal plate tectonics is kind of weird, because when you've got very large, semi-stable continental plates rubbing against each other, you get localized breaks and everything, and then all of a sudden crystals going. This would lead to, like, tectonic crystalline explosions, not just quakes.
Well, the way out of that, of course, is if you want tectonics, but you don't have, and you big scale tectonics, but you don't have plates, just drop something on it from above.
Okay, there we go.
When in doubt, this is the put a bird on it of planetary geology, throw an asteroid at it.
Yeah.
It solves a lot.
I could see that happening, and that makes sense, because there's the scene where Ray is like using the Force to get everybody out of the big crystal tunnels. Those are not crystal rocks. They're not crystalline at all. They're actually water-formed, smooth, granitic conglomerate rocks. That right there, I'm in my mind, okay, so we had water. We have some sort of sedimentary action going on. But where did all the water go, and why is the crystal core of the planet that the Falcon is flying through, how did that work? I like the idea of, oh, look at this beautiful, beautiful place. Throw an asteroid at it.
When in doubt, throw an asteroid at it. And speaking of, actually, we've been talking about all these plants. We've been talking about planets. Not plants. No plants in this panel.
There could be fossil plants.
So we've been talking about desert planets. We've been talking about water worlds. We've been talking about salt planets. And all of these planets are round, which means that they're all going to work a certain way. They're all going to have gravity that works a certain way. And this is where I look at Asgard, and I look at Dave.
Oh, sure. So, Asgard, the way that Asgard, if you look up like the picture of Asgard from afar, is this flat plain with mountains on it, which is very confusing. These beautiful, majestic mountains, and then water just kind of falling off the side. And it reminds me
like
of
Discworld with seriousness.
Like Discworld. And it reminds me of the levels in Super Mario Galaxy, where they were all floating above a tiny little black hole, so that if you ran off the side, you would just fall down into the black hole. And as far as how you get that, I know we have the planetary people. I will defer to planetary people for flat planet geology.
Yeah, how does that work?
How do you get mountains on it?
Drop something on it.
Like, say you have collisions from like protoplanetary. Like, how do you end up with like mountains on Ceres or the asteroids? Like, it's got a beautiful little like fan freaking tastic conical pointy ice mountain, and we're like, oh, cool. How do you do that?
I also would like to note that if it is, so Asgard is flat, it is not spherical. It does not rotate around a star, so it doesn't circle around a star, and it does not spin, and it does not clear objects from its path because it does not rotate around a star. So does this mean that it is like Pluto and not actually a planet?
Oh, it totally isn't a planet, by the IAU definition. But nor is anything that isn't in our solar system. The International Astronomers Union only says things inside our solar system are planets, and everywhere else is not.
Which the planetary science community does not recognize, officially as of a year ago.
Yes. And having just been at an IAU meeting directly before this, and having seen how they function in terms of their policies, I am definitely on Team Planetary Society, just from like a purely procedural standpoint.
So we keep coming back to this common theme of when in doubt, throw an asteroid at it.
I have something about Asgard about that.
Okay.
So, if you notice, any kind of planetary impact on the edges of that, might flip it, something like that.
Oh my god.
But what does Surtur do? right through the center, the most stable part of the floating disk planetoid. I liked that fact, that he just went like right for the middle.
So you were talking about, the put a bird on it of planetary geology, which is to throw an asteroid at it. And I've noticed this actually in sci-fi, that whenever you're really pressed for a plot point, just throw an asteroid at it. Like, has anybody else noticed this? This happens a lot. And so I was wondering, we're getting all these things like, Asgard and salt flats and stuff. What happens when you impact things with high velocity other space things, Scott?
They get compressed very dramatically, and then as soon as you remove the compression, they explode. And so you could get a big shard. I mean, if you have the greatest planet of all time and you just break it apart, you could end up with all kinds of flat things spinning out through the universe.
And then how do you get the mountains from there?
Well, and all impacts, I mean, you just look up at the moon every night, and you're going to see mountain ranges all over the place. All of those are created by impacts, just from the uplift of rocks that were on the rims, and the uplift of rocks that were actually quite far down to create mountains in the middles of a lot of the impact structures.
And you also mentioned to me something that I found really fascinating in our prep for this panel. You mentioned that when it comes to throwing asteroids at things, that big budget films often get more wrong than small budget films or small budget TV shows.
It's kind of an odd thing I've observed, because that's what I've observed. The thing that's pretty, people get, I guess with the big budgets, you really want to impress. You want that big action theme sort of environment, and so all those asteroids you're talking about, and the meteors that come in particularly, are these big screaming blazing balls. And
that's what she said.
Yeah. And that gets attention. Some of the more subtle things I've seen on some like miniseries things on TV and whatnot, you're sitting there and you're thinking, gee, this can't be right. I remember one, I can't remember the name now, it's probably 10 years ago, with one where they talked about this asteroid that sort of was out there and started breaking into two. It was this mammoth thing, and it sort of spontaneously broke into two, and it's sort of on its way. And then there are these sort of precursors of hitting us that are like things out in advance of it rather than the big objects. And it's like, some of that stuff really is probably the way it works. The biggest danger out there in the geologic record, as we see here on Earth, are actually some of the ones we don't know are coming. We spend a lot of time mapping ones that we know are out there, but suddenly things get shaken up and things run into each other, and it can create havoc that then these guys can go and study.
So, speaking of havoc.
Real quick, I just looked up Asgard, and it looks like it may be a remnant from a prior impact, because it's not just flat with water. There's an actual, conical, root. It's just pulled up the Thor Ragnarok screenshot. So perhaps Asgard was a big round planet, and then was formerly destroyed by Surtur. And then this is the second Asgard. It's like an ejecta plate.
In which case, that also explained the mountains and all that, because you formed the mountains when it was still a planet.
Right.
And then this is just the relic terrain chucked off into space.
So there are just chunks of Asgard floating through the 9 realms, waiting to impact other planets.
Yes.
What if other bolide impacts are parts of Asgard coming through gates and hitting other planets?
Whoa.
This is my new headcanon.
I accept this headcanon.
This is my new headcanon too.
Okay, so we were talking about different ways to form mountains, and we talked about asteroid impacts, which is my new favorite way. But we're also talking about tectonic plates, and when we talk about volcanoes. And so I particularly wanted to address the recent Jurassic World volcano. Dave.
So, Jurassic World Fallen Kingdom. So, there's a volcano on this island we've been on for 25 years, suddenly. And so you have this volcano in the beginning of the movie, and it's erupting. There is a long trope of dinosaurs and volcanoes, which isn't totally untrue, but every old dinosaur movie and a piece of dinosaur paleo art has to have a volcano in the background. And this is out on that island off the coast of Costa Rica. And in the real world, here where we all live, a lot of that kind of volcanism you're going to see in places like that is subduction volcanism. So we were talking about when you have your continental plates, as Trevor was explaining, coming together, not only are you pushing up, like a rug, you're bunching up the crust, you're also causing all sorts of crazy melting and heat exchange underground that's going to create these the ingredients you need for volcanic eruptions. And so it makes sense to have a volcano out there. But one of the things that I heard a lot of geologists are complaining about is the way that volcano explodes is a lot more Mount St. Helens than Kilauea. And if you look at Hawaii, Hawaii has these, just like Mika was explaining, these nice, goopy, flowy lavas, these basaltic lavas coming out of your volcanoes, as opposed to the more continental kaboom volcanoes.
That's in the movie.
It's at least consistent with the shape. The volcano in the movie is a pointy stratovolcano, which you would expect to have, like, explosive volcanism. Although if you do, you cannot outrun a pyroclastic flow. That is not a thing that is going to happen. And if you do somehow not get, like, taken out by, like, the lava-y bits, you're going to be boiled, you're going to be suffocated, you're going to have toxic gas, and on top of all that, you'll be inhaling tiny little shards of glass, because volcanic ash is not like combustion ash. It's shards of glass to just, like, perforate your lungs. Like, it's just a terrible way to die in every possible way, and you're not outrunning it.
I did the math on that for another talk, and a 1 ton boulder being thrown at pyroclastic speeds would impact Chris Pratt with the same kind of newtons of force as a single RS-25 space shuttle main engine at full thrust.
Which is getting right back to the if you don't like things, just throw a rock at it.
Yes.
Unfortunately, this means that somebody really didn't like Chris Pratt, which is a little unfortunate.
So now that we've tossed a rock at Chris Pratt, now that we've thrown rocks at planets and Chris Pratt, I actually wanted to talk about what's going to happen to Chris Pratt later. And I would like to talk about fictional fossil records. Because this is something that I think many sci-fi planets kind of overlook. The idea that if you have, say, a salt planet, if there's life there, and there is life there, there's like crystal foxes and stuff. So, like, there's going to be fossil records of that life, is there, in salt planets?
Trevor, I wanted to ask you this question.
Oh, crap.
How would fossilization look on a salt planet?
Weirdly enough, I don't think that. Well, now that we figured out Crete is just that salt region. Say one of the. I can't believe I actually know the names of these. One of the Vulpixes.
We're going to get to that in a second.
Yeah, one of the crystal crystal foxes. Yeah.
I'm so proud of you.
If it died within that incredibly large salt basin, perhaps it would have more desiccated and then kind of more preserved.
So we'd have, like, crystal fox jerky?
Yeah.
Like a mummy.
Yeah, right. But I can't really see how, well, one, there's no visible water on that planet, and a majority of fossilization has to have water because the local sediments are waterborne into the bones of the critter, and then replaced. They replaces the calcium and all of that. But if the crystal critters at least have a crystalline coating,
they're like half fossilized at birth.
yeah, they're not a carbon-based. Maybe they're a silicate-based life form. Weird.
I actually hypothesize that they're in a commensal relationship with diatoms. That's my headcanon.
We could also do something like stromatolites or like algae rock hybrids.
Yeah.
So we could have them be like crystal fox hybrids or like decorative where they'd like attach all the crystals onto their fur. But either way, they're pretty fossilized.
Yeah.
They're like mobile fossils.
Well, they're like corals, building your skeleton out of mineral. You've got this calcium carbonate mineral you're building.
Well, in that case, we could actually have a crystal fox fossil if it was one of the rarer types of fossilization, such as like an Aeolian collapse, where something is covered by a sand dune or something like that. A majority of Velociraptor, Protoceratops specimens and all of that are actually from trapped sand dunes. They get covered, they get suffocated, and then just slow tectonic pressure kind of turns it into sandstone around them.
That's really sad.
Yeah, that's also a little
possible.
bit like the Burgess Shale in British Columbia.
Yes.
The first place we started getting soft-bodied fossils was a landslide.
Yep.
Squished everything and saved all the little squishy body bits. So we can finally see them, and then we saw like all these weird body types that we've never seen before. By which I mean to be like one of the critters is a hallucinogenia.
Yes, that's so cool.
Explain why it was awesome. So to give
Please
like,
talk about
context, is that when they first tried to figure out this fossil, they put it together upside down and backwards.
Oh my
And it was in 3 pieces. So it's basically this. Yes. Okay.
My art thing.
Yep.
Oh, there's a bigger
Draw.
whiteboard behind you if you'd like to draw larger.
Oh.
Okay.
So
Okay, while our artist in residence gets to work.
basically, it's this weird nudibranchi-looking thing that has kind of a definitive head and kind of a definitive tail, but not really. But it's a tube with spikes everywhere.
On both sides,
top and bottom. So what we thought were the legs, it was flipped upside down. So it actually turned out to be that those were the dorsal, what we believe are the dorsal spines, and then the larger spines that we thought were the dorsal spines are apparently the spines that it uses for mobility. This thing is effing bizarre, but because of those kinds of landslide fossilizations, we can find these really.
So, for those who will be listening to this, what we're looking at here is, you can't draw.
No, he really can't, because that's
what it looks like!
Yes!
That is an accurate drawing!
Nature can't draw. It's like a worm with a comb on either side.
You need
It's
to
a
start
worm
with,
that doesn't know which way is up.
dog, and then you put like a ping pong ball on the end and throw some eyeballs on there. Yeah. And then you take a bunch of toothpicks and jab it up the bottom, and those are the legs. The spindly bits are the legs. And then you take like weird leafy things. Like what we have is our leafy thing here.
like weedy sea dragons.
There we go, like sea dragons. And shove them down the back as its spines and have them wibble wobble everywhere.
In 2 rows.
And this is an actual creature.
What's his name?
Hallucinogenia.
Hallucinogenia. Named because they didn't believe it.
Yeah.
And they went,
Oh my
"This is
god,
so weird."
we have a Google image search.
Yeah.
Wow!
See? It's an accurate drawing.
Please go around and show the class. Thank you.
I feel vindicated.
Yes.
Hallucinogenia is probably spelled a lot like hallucinogen.
Yeah, look for a hallucinogenic fossil and you'll find it anywhere.
For a reason.
Yeah, British Columbia is currently voting on what our provincial fossil will be.
It needs to be that.
We did not make hallucinogenia an option. We picked 2 other Burgess shell fossils, and I figure it's the biggest tragedy of our province so far, particularly as well. We are well known as an exporter of adult herbal products.
Look, California just got a state fossil, and it's a hadrosaur that's not actually found in California. It was a washed-down transport fossil from where? Probably Canada.
So we were talking about these fossils that are formed via landslides, via long-term sand compression. What kind of things are you going to...
Our audience members are slowly doing...
What are your fossils going to... So I'm assuming the salt compression is going to happen on your desert planets. The sand compression is going to happen on your desert planets.
Oh, sure.
And we talked about salt planet. What about water planets? Because presumably landslides are a lot gentler underwater.
No.
Oh, they're not?
No.
Oh.
Why would you think that? No. Air is a fluid and water is a fluid. So what makes any difference, right? You just get turbulent flow, and you just have like the sediment just gets bigger and cloudier and poofier. That's all. Like that's it. It's air is a fluid, water is a fluid, everything's a fluid, everything is green and tastes like dinosaurs.
If you have learned nothing else today.
I throw an asteroid at it.
It's like putting eggs on things or bacon. Yeah. So now we've talked about landslides, we've talked about planets, we've talked about plate tectonics, and now I want to talk about the weather. Because it's Monday. I want to talk about the weather because it's more important to know whether there will be weather than what the weather will be. Does anyone know that reference? Please. Oh. Go read the Phantom Toll Booth, I'll wait.
No,
anyway.
I missed.
So I wanted to talk about The Martian, because I feel like we can't have this panel without talking about The Martian. And The Martian was lauded for its relative scientific accuracy, except for people got mad about the weather on Mars. Would you like to talk about that?
Well, before I came in here today, I just checked. There's actually a NASA white paper that's written on this, sort of pointing out the errors in having this dust storm come up and actually topple things over. And there were a lot of colleagues and people, interested parties at the time that, like you said, got mad at that aspect. And I scratched my head because one of my first advisors was the guy who directed the NASA wind tunnel for studying Mars. And he pretty clearly taught me that these things should be pretty dramatic. And that's what the evidence from experiments was. So I was really scratching my head. And when you go through the explanation, I hope everyone's heard about, in one of these massive dust storms, that you have a very low atmospheric pressure, so you don't topple things over like you have in the movie. But the thing people seem to have forgotten is that the air pressure of Mars at that point is irrelevant, that you have a bunch of suspended dust particles, because now the pressure involved isn't the pressure of Mars right now, it's the what's called the dynamic pressure of all of those suspended dust particles, which can be pretty dramatic. Now, in a big global dust storm, most of those particles are suspended, so they're not really being blown along at that point. It's just taking them a very long time to settle out. So yeah, at that point, you don't need to worry about some great wind. But when those things initially get kicked up, or when the storm involved is small, like a large dust devil or tornado, you could actually have a pretty dramatic situation, because it does take a little while, because Martian dust is very fine. It takes a little bit more oomph than it does on Earth to get this stuff aloft to start with. But once it's aloft, it's going to be like a airborne mud flow coming at you.
Wow. So I wanted to talk a little bit more about storms, and particularly about a very long-lasting storm system in N.K. Jemisin's The Broken Earth trilogy. So there are storms that last for generations. And I wanted to talk about the relative realism of that.
All right, so I actually went out for the book launch of the last part of this trilogy and was the entertainment during it, because it turns out if you read too much of the book, it's a spoiler, so you bring in a disaster scientist to just talk doom, and it worked really well. So the concept in Broken Earth is there's the seasons, which are like periodic apocalyptic events, and they've happened over and over and over again. And then we have different humans with different types of abilities, including some who have the mental capacity to suppress disasters or, to trigger them. But what I really, really, really like is not necessarily any of the individual components of like giant crystals with different properties, or you get into hardcore spoilers territory when you start going into the interior of the planet, where there's a lot of really cool things to do. Like there's awesome geology to pull apart there. But what I really like is actually the cultural response to being in constant trauma and in constant disaster mode. And what they do is they transmit disaster preparedness information through storytelling. And they use practices that you can find in various indigenous cultures around the world. Things like how to build a landslide resilient building is different than having one that is to good seismic codes. And that you would be able to read the landscape to decide, don't build there, it's actually a floodplain, or clear away all the clutter nearby so you don't, your building is less likely to catch on fire. And all of this is interwoven into the story, and I absolutely freaking love that. The other thing that I really, really, really love about it is more subtle. And that is that we have a slow-living fossilization of characters. So,
what?
Yeah, so this is, I know, both the paleontologists, I'm going to give
really
you
gotta
enough
read this
context
trilogy.
for them to jump in. I will say that it is one of those sci-fi books where you have to learn the vocabulary for the entire world in order to get there, so it's hard going for a chapter or two, and then once you've gotten the background jargon, you're set. So don't give up in the first chapter. So what the idea is, in the real world, we have biomineralization. There's all sorts of ways that biology and geology interact. You are growing minerals right now. Lots of different types of minerals right now. And there are a bunch of minerals that only exist on Earth because biology has happened. There's 4,000 minerals that only exist because life has existed. And if we found them on other planets, we'd be like, wait a minute, something was living here once upon a time. Or we'd be really, really confused. Either way, that's kind of the nature of science. So in this, by doing certain activities, it results in rapid fossilization of part of the body, with actual mineral replacement. So they have to be
in contact with the Earth and all that, and it, like, again, explaining the context of how it makes sense gets into spoilers territory, but it talks about the ordering of the minerals and about how, like, then they are no longer able to, like, move it. It is now a rock.
You were
that they
talking
put,
about
like, a
full soft tissue mineralization?
Yes. So biologist in the room over here, and actually the first thing I think of is this horrible disorder called, I want to say fibrous ossificans progressiva. I don't know what the common name is. I only know the Latin name. But this is a terrible disorder in which your ligaments slowly turn to bone every time they are injured. With the net result that people end up in these horribly painful, contorted postures. So, yeah, that's what I'm thinking of. But fossilization works too. Anyway, we want to make sure that we have plenty of time for questions. So I just have one more question. I'd like to go down the panel. And I'd like to ask you all, if you could live on one fictional world in any universe, what would it be and why?
Crap.
Go.
Well, I'm actually, go back to the beginning here. I'm actually pretty good on Tatooine because I cannot stand cold places. I lived in the desert for about 7 years in Arizona, and I've also lived for about that period of time in New England. I will take the blazing heat any day.
See, I'm as a paleontologist and being born and raised in Los Angeles, I'm very used to desert, and I really like the idea of Tatooine. But genetically, I'm Canadian. I'm going Hoth. Because, man, one, I like the idea of cold a lot. Two, imagine the hockey on Hoth. That would be great. And three, they have indigenous animals there. And there is a possibility of fossils being found through, like mammals, permafrost. It's like, think of the evolutionary path of the Tauntaun. I could be like Hoth's first permafrost paleontologist. I dig Hoth.
I was thinking very similarly. When I watched Avatar, the movie, on Pandora, I spent the entire dang movie going, all right, why do some of them have 6 legs?
Oh, thank you. Thank you.
And what is the evolutionary history of this wacky planet? I want to go there so I can find out.
Yeah,
I want to be a Pandoran paleontologist. Now, I guess I don't know how much of it is terrible rainforest.
Yeah, I'm really not fond of rainforests. I've done enough. I live in a temperate rainforest, and I'm okay with that. I'm not good with tropical rainforests, but like anywhere where my hair has a danger of mildewing, I'm really not that fond of it. I'm going to break your question a little bit. I want to be a field planetary scientist. I'd like to do field geophysics, but have a spaceship to go and just start poking all the planets. I'll also take field astrophysicist, but admittedly I'd be less good at it. I'd be kind of the B string field astrophysicist. But I'd like to go find like a bunch of different worlds and try and figure this out because like our understanding of planetary science has taken such a beating over the last like couple of decades of discovering all these exoplanets that I'm starting to think our fictional worlds are really unimaginative compared to reality. And I would like to just kind of go around and find some of the more bizarre worlds out there. Like the ones that are vaguely equivalent to the TRAPPIST system where you could like throw baseballs between one world and another, which is an actual exoplanet system we've really honestly found. So I want to find those.
So now I'd like to take the opportunity to open it up to questions, and this question series is going to have a very particular format. Okay, are you ready? The question format is pick a planet. It has to be a fake planet. Please pick a planet, pick a universe, and we're going to attempt to break our panel.
Oh, great.
Hey guys.
Throw a planet at us.
Nerd, or just Tamriel in general, from the Elder Scrolls series. I'm very interested in the geology there, especially like Skyrim and all of the weird mineral deposits that seem to kind of go together haphazardly there. So,
all right, the Elder Scrolls and Skyrim.
Haphazardly, yeah, and like fossil dragons and all. So Tamriel is in this weird kind of hybrid between Tolkien and Forgotten Realms from Dungeons and Dragons. Yeah, that's weird. Mainly because of you've got, in a very close proximity to each other, a massive volcanic area, and just a little ways away, we don't really know how large the planet is, but just a little ways away is basically Norway.
So I actually have a geological map of Skyrim.
Oh, please.
Yeah. So I have a
it's
geological map of
messed up.
Skyrim based on outcrops. So you can tell that it's a fun game when the geologists are like, well, you had a thing for me to do, but I'm not just going to go around and try and figure out the geology of it. I did this in Dragon Age. Where there is, to the south are the iron deposits. So that's where you find all your iron ores and all that. To the north is the conundrums. And it has like a little bit of some ultralim in it. Then in between the two, you've got like this layer of quicksilver and silver. And it actually follows a topographic thing. So the closest equivalent that we can find in our actual solar system is it follows the topography, vaguely speaking, of Mars, of having a high hemisphere and a low hemisphere. How exactly you get one that is an iron high hemisphere with a band of silver with coriander on the other side in the low bit, I'm not really sure. But I'm going to ask, like, maybe we have some, like, absentee oceans going on.
Maybe, but I just found a diagram of Skyrim specifically, and there's a whole lot of mountain ranges there. One of them is a massive upthrust peak. You've got divergent plates going on. It's
a
you dropped something on it.
World.
Oh yeah. No, obviously something was dropped on this.
And by the way, we know. We know from one of our space missions to a comet that comets actually have silver in them.
Ooh, sparkly.
So maybe we chucked a comet at it to give it that band of silver with, like, the remnants left over. And that we've got enough detritus that was, like, for whatever reason happened to be asymmetrically thrown out to have more mountains on one side than the other.
I found all the continents for the Elder Scrolls Online once.
All right, we're moving on. Next planet, next planet.
Please do, because this is too much.
For the sake of the podcast,
We could do a panel on this next time.
We'll include links.
What about Mercedes Lackey's Kern?
Oh, and McCaffrey's Kern.
I'm sorry.
It's okay. I have to say, though, I love Mercedes Lackey. We should be friends.
Done.
Alright, so the Kern world is actually fun from a biological standpoint as well, because they've got the whole genetic engineering thing going on. But what makes Kern fun is we've got a two-continent system, northern continent, southern continent. The northern continent has a whole lot of volcanoes and mountain ranges in which they're all dead. Like, all of them are dormant volcanoes that people are now living in. And there is a regular bombardment from space. Like, not of asteroids, but of things like hitching rides on asteroids. But you can kind of think of it as being like teeny tiny little asteroids. And then the southern continent is more geologically active with only one major volcano going on. So there's the context. I'm going to let, like, other people, especially, like, it's asteroid central, is this entire world. Of just, like, literally every few centuries you get more coming in. So how would you get periodic bombardment by asteroids?
Things hitting things other places. And I mean, that's what happens here, is we have some things out there and they get hit, and you have a lot of things come in and hit other things. It's what I referred to one year here is the galactic billiards. So and that's what happens, is you run into one thing, it busts apart, and they go off on trajectories that you may not imagine. If there's a sun or multiple suns, they go into some sort of orbits, and then eventually they run into things, but then they might get hit and and they have fragments that run into something faster.
We have periodic meteor showers, like the
Perseus.
and all that.
But those are just little ice crystals left over by comets that have left their tails in orbit around the sun, and we happen to go by them. But it's they're
amp it up.
Yeah.
Really big, biologically nasty comet.
Exactly. And so the way the volcanoes are actually the bit that bothers me most, because the geography of the volcanoes, like, they need to have the pointiness, they need to be going through continental crust, which is cool. They're on a continent, that makes sense. But they aren't in any way that would be made by, like, continental boundary collisions. So that means we have to have, like, hotspot volcanism happening underneath the continent, which is weird. And it all has to be dead, which is weird. But if we roll with all of that and just be like, yes, it happened, then you can start having them living in it by having lava tunnels. So does someone want to explain what lava tunnels are? It looks like you're nodding there, of how you get them in volcanoes.
Oh, sure. Yeah. Tunnels carved out by lava.
Well,
actually,
now,
so clever in geology.
I would just like to pause for a moment and say this is the one geological thing that I actually know something about, because 48 hours ago, I was in a lava tunnel in Iceland.
Actually, the first 10 years of my career before I started doing asteroid impacts was entirely devoted to lava tubes all over the world.
Okay, you talk first. It was lovely. You should go.
I forgot these things all have hydrothermal heating sources, so they're not completely dead, they're just non-eruptive. So there we go. Hydrothermal inside of lava tunnels.
So lava tunnels or lava tubes are pretty simple. Is you have lava coming out and lava cools against the air, the water, whatever, and it cools on the outside first. So it cools and basically insulates itself, so the inside keeps moving, and those can extend out very, very far, particularly if the outside's very hot, like here in our solar system on Venus, because the atmosphere is so hot, the insulation is more effective, and these things can go out, individual lava channel and lava tubes can go out 3,000 kilometers. But they can be very tiny, or they can be huge. I've been in some that are rooms the size of limestone caverns, and they are an excellent place to hide out. They're an excellent place to do all kinds of unmentionable things, and I've seen evidence of that here on Earth.
They cleaned that lava tunnel out.
How stable are they?
Remarkably, reference the Romans. They're arches, and they're beautifully stable. Until, you happen to be in the one place they're not. But the thing is, as long as you're not in them while they're running, which you probably wouldn't be anyway in 1,000 degree plus lava, most of the holes in them, and this is probably mostly true when you see these on the moon and Mars and other places, the collapses probably mostly occurred during the eruptions while the stuff was still flowing. Once it's over, those arches are magnificent, so they're probably pretty safe. Now, the problem on most worlds is, again, you drop things, and dropping thing on a lava tube is not a defense.
All right. Well, unfortunately, I hate to tell you guys this, but we're completely out of time. This was wonderful. Thank you so much, panelists. And if you want to continue conversations, we have an overflow room across the hall. So thank you all very much for coming. Now we're going to actually go. We got to play before. Awesome. If you'd like to learn more about Mika McKinnon, David Moscato, Scott Harris, and Trevor Valle, we've linked to more information about them and about some of the fictional worlds we talked about at scienceforthepeople.ca. You'll also find links to Twitter, Facebook, and iTunes, where you can listen to past episodes, subscribe to the show, or leave us a 5-star review. You can also find our Patreon page, where you can support more shows like this one with a monthly donation. Thanks for listening, and we'll see you next week on Science for the People.
Science for the People is produced by Rochelle Saunders and edited by Ryan Bromsgrove. Helen Quivalon is our publishing liaison. We get research help from Josh Witten and consulting support from Desiree Schell. Our frequently seen guest hosts are Marion Kilgour, Anika Hazra, and Jessica Yaros. Our theme song is called Binary Consequence, and it was written and recorded by Fractal Pattern. Science for the People is entirely listener-supported. You can find us on Patreon, where you can support us with monthly donations in any amount, or you can send us a one-time donation in any amount via the donate page of our website. Science for the People is created in partnership with the Skepchick Network, a collection of blogs, podcasts, and video content focusing on the intersection of science, popular culture, politics, and social justice. You can find out more about Skepchick at skepchick.org. The show is hosted by science news writer Bethany Brookshire and me, Rochelle Saunders.